This video is about the trigonometric ratios. As you can see, they're on the page here. Sine theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. Tan theta equals opposite over adjacent. Cosec theta equals hypotenuse over opposite. Secant theta equals hypotenuse over adjacent. And cotangent theta equals adjacent over opposite. What we are talking about here, when we're talking about theta and opposite and hypotenuse and adjacent, is a right-angled triangle. We have our angle theta. We have our opposite side. We have our adjacent side, and we have our hypotenuse. Hopefully all of that is familiar to you. That's certainly at least for sine, cosine, and tangent. The thing that you're going to be introduced to in this video is a slightly different way of thinking about these ratios. Let us look at the unit circle with a radius. The unit circle is in blue, the radius is in red. I have drawn a line that's perpendicular to the x-axis, and it's connected to the radius on the circle. You can see that this triangle, this changing triangle, is always a right-angled triangle, and the key thing is because the hypotenuse is the radius of the unit circle, it means that the hypotenuse is always of length 1. So that means that when we're looking at the ratios, if we say that the hypotenuse equals 1, we can see that sine theta, if our hypotenuse is 1, sine theta is opposite over hypotenuse, opposite over 1. So in this case of this very special triangle, sine theta in fact equals just the length of the opposite side. Similarly, cos theta is adjacent over hypotenuse, so adjacent over 1. So in this very special case, this particular triangle, it just equals the adjacent side. So, and what that means in terms of coordinates is this point on the unit circle has an x-coordinate. That x-coordinate is the length of this side, which is actually the adjacent side. So another way of thinking about it is that cos theta equals our x-coordinate and sine theta equals our y-coordinate. And these coordinates are the x and y of the point on the unit circle. So if we look at our unit circle, we can see here we're at the point 8 0.6, so that would be written 0.8, 0.6, and that would mean that our sine of this, whatever this angle is, sine theta, is going to equal our y coordinate. Our y coordinate is 0.6, while cos theta is going to equal our x coordinate, which in this case is 0.8. This only works for this special triangle, but it's a way of defining sine and cosine of theta. In the next two videos we'll look at how to define the other four ratios using the unit circle.